Well, we have that the derivative of the sine x is cosine x, and the derivative of cosine x is minus sine x. There's four other trig functions that I want to take the derivatives of now, and I'm going to use this information to get that. So, for instance, what I want to do right now is I want to look at the derivative of the tangent x. Okay. Well, I could go back to the limit as h goes to 0 of sine x, not sine x, but tangent x plus h minus tangent x all over h. Use the definition. However, I don't want to do that. I want to use this information. The thing is, I know that tangent is related to sine and cosine in the following way, right? Tangent of x is sine x divided by cosine x. So to say that I want the derivative of tangent x is to say that I want the derivative of this quotient of sine and cosine. And hey, I know the quotient rule. I can do that. So I've got the bottom turns into the bottom squared. Then you've got the bottom times the derivative of the top minus the top times the derivative of the bottom. Okay. So now we'll take those two derivatives. I've got a cosine x times the derivative of sine x. Well, the derivative of sine x is cosine x minus sine x times the derivative of cosine x, but the derivative of cosine x is also minus sine x. And that's all over cosine squared x. So now, what do we have? Well, that looks like a cosine squared x minus, oh, but the minus minus actually becomes a plus sine squared x. And then I've got a cosine squared x on the bottom. Feel like canceling those out? Resist that temptation. This cosine squared is not a factor of the top. It is being added to the rest of the stuff. It's a term. Factors are multiplied. So this doesn't cancel out yet. However, there is something nice that happens because that numerator is cosine squared x plus sine squared x, and it doesn't make any difference what x is. Cosine squared x plus sine squared x is always equal to 1. So that's beautiful. So I've got 1 over the cosine squared x. That looks kind of funny. Cosine squared x. But cosine squared x, sorry, 1 over cosine x is the secant of x. So 1 over cosine squared x is the secant squared of x. Let me refresh here. The derivative of the tangent of x with respect to x is equal to secant squared x. Okay. All right, let's do the cotangent because that's very similar. If I want the derivative of the cotangent x, that's going to be cotangent is the cosine of x divided by the sine of x. So to take the derivative of the cotangent, I'm going to take the derivative of this quotient. And I know the quotient rule. I just used it. Let me see. But now sine and cosine are flipped from where they were before. So the denominator becomes the denominator squared. And then I write that up here, sine x times the derivative of the numerator minus the numerator times the derivative of the denominator. All right. So here we go. I've got a sine x times the derivative of cosine x. The derivative of the cosine x is negative sine x, so there's the negative sine x, minus the cosine x times the derivative of sine x. Well, the derivative of sine x is cosine x. And I've got a sine squared x on the bottom. So I've got a minus sine squared x minus cosine squared x on the top and a sine squared x on the bottom. You want to cancel out those sine squareds? Don't do it. Just don't even think about it because that's not a factor of the top. It's a term, right? You're subtracting. You got to be multiplying if you're going to cancel. So here we go. But that top is nice because if I factor minus 1 out of it, this is minus sine squared x plus cosine squared x over sine squared x. And cosine squared x plus sine squared x or sine squared x plus cosine squared x. Either way, addition is commutative. Either way, they add up to 1. And so I've got a negative 1 on the top and a sine squared x on the bottom, which is equivalent to negative cosecant squared of x. So what's the derivative of the cotangent? It's the negative cosecant squared of x. All right, so we did the tangent. Derivative of tangent was secant squared. The derivative of cotangent is negative cosecant squared. Well, they're kind of the same. They're certainly similar, but cotangent is negative. Actually, that makes a bit of sense to me, because if I look graphically here, if you look at the graph of the tangent curve, right? It's got vertical asymptotes in it, right? It's got these things. It's always headed uphill. The slope is always positive. So the derivative of the tangent x had better always be positive. Well, it's secant squared x. That's always going to be positive, because I don't care whether the secant's positive or negative. You square it, that's positive. On the other hand, if you look at the cotangent, which is the reciprocal of the tangent, it's always headed downhill, right? This is the cotangent function, so the derivative of the cotangent function had better be negative all the time, and well, it is. It's negative cosecant squared x. Cosecant x might be positive or negative, but when you square it, that's positive, and then when you take the negative of that, that's negative. It's always going downhill. The slopes are always negative, so the derivative is this negative cosecant squared. Okay. Now we got two more to go. We did tangent and cotangent. Let's look at the derivative of the secant. I'm going to write that as 1 over the cosine and take the derivative of that. All right. I'm doing that because I know how to take the derivative of the cosine, I know how to take the derivative of 1, and I know the quotient rule. So here we go. Because it is a quotient of those two things. I've got, why do I keep doing that? Here's the denominator squared, and I've got the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator. So, derivative of 1, well, that's 0. So this is a 0 minus the derivative of the cosine, but the derivative of the cosine of x is the negative sine x, so that negative becomes positive, and you got a cosine squared x on the bottom. So sometimes you might see the derivative of the secant written as the sine x divided by the cosine squared x. But usually we don't write it that way. Usually we think of it in terms of this. This is 1 over the cosine x times the sine x over the cosine x. And 1 over cosine x is the secant x, and sine x over cosine x is the tangent x. And this is the way you usually see it written, that the derivative of the secant x is the secant x times the tangent x. Okay. It is equal to sine x divided by cosine squared as well, but usually we write it this way. Okay. One last one to do, and that is the cosecant. So looking at the derivative of the cosecant of x with respect to x, I'm going to think of this as cosecant is the reciprocal of the sine. So I'm going to write it this way because I know how to take the derivative of sine x, I know how to take the derivative of 1, and I know how to take the derivative of the quotient. So here we go. I've got the denominator squared. Whoops, sine squared x. I've got the sine x times the derivative of 1 minus 1 times the derivative of sine x. And here we go again. The derivative of 1 is still 0, so this is a 0 here to start with. And then I've got a minus the derivative of sine x. The derivative of sine x is cosine x, and then I've got a sine squared x on the bottom. So sometimes you might see the derivative of the cosecant written as negative cosine x over sine squared x, but generally we don't leave it that way. We write it like this. So this is negative 1 over sine x times cosine x over sine x. Right. So this is negative cosecant x times the cotan x. Let me shrink this down a little bit. The derivative of the secant x was secant x times tangent x. The derivative of the cosecant x is negative cosecant x cotan x. Right, they're very closely related. Do I expect that you memorize all these derivatives of these 6 trig functions? The answer is, of course, no. Do I expect that if you don't remember them, you can figure them out? The answer is, of course, yes. Um, Sine and cosine, right? We did them graphically, we did them algebraically. Those two, I think, are pretty straightforward to remember. Derivative of sine x is cos x, derivative of cos x is negative sine x. Then you just use that information to derive whatever derivative you need. I cannot tell you how many times as a student I did this because I couldn't remember. Is it positive secant squared? Is it negative secant squared? Is it... And so I just do it. It's, well, it's sine over cosine. It's a quotient. Do the quotient rule and, a little bit of trig identity, and poof, you got it. If you do it 5, 6, 7, 8, 10, 100 times, I mean, I have no idea how many times I did it because I can't remember. I can't remember. Finally, I got to the point where I could remember it because I could actually just see the proof in my head because I'd done it enough times. I don't memorize that. I just did not memorize that. I figured it out 100 times and then finally it stuck. Likewise here, I can do the cotangent because I can do the quotient rule. I can do the secant because I can do the quotient rule. I can do the cosecant because I can do the quotient rule. All right, figure it out each time. You do it enough times, then you'll remember it.